ladies and gentlemen, whoever may be watching this video, tonight I'm going to be testing this Marathon motor. It's not only bearing failures, because obviously you can see the spins. The fan did move freely. I mean, this meter here, work with it in the rain, gets wet, boom, half the functions don't operate. I use this one in the field currently for generators, and I use this X-Tech for generators. Right now I'm actually looking at between the Fluke 28II, the Fluke 87V, the 376 FC. One of my subscribers has recommended, says it's an excellent meter. Not really looking at the 289, it's really not what I'm looking for. But let's go back to what I'm doing here. So, as we all know, here's a good motor. And we're going to compare a good motor to a bad motor. Well, the problem with this motor is we lost a winding. Now let's start off by testing a good motor so everybody can see how a good motor is supposed to test. I'm going to use this meter because this is my bench meter. This doesn't get used for anything else but working on this bench. I already on this meter have my alligator clips to make it easier. Now, for anybody that doesn't know, these are speeds. When you have multicolor wires on a condenser fan, changes its horsepower or its speed. So you're going to have a lower resistance on your higher speed. Check our higher speed, and our meter is showing 11.6. Now let's change our speed to the lower speed. We have 17.8 we are testing. Let's change. Now this one with the white wire, when you have this setup, this and the white wire are connected to the same coil in the motor. Oh, I need a new battery on this one, but we're still testing. We have almost no resistance, but this is a common, which is why you can hook up the two wires, this, and the capacitor does not have to be connected to power because it's going right back to there. Now this is the largest one. This is where your capacitor is connected to. This is required to help start and run on this kind of motor. On a PSC motor, it actually, and as you can see, as I'm spinning the motor, I am changing the resistance. I'm going backwards, but you can see it's moving. This is the winding that keeps the motor spinning. What happens with the capacitor is it helps create the magnetic force on the motor to keep it rotating. It helps it start rotating, but it also stays in the circuit because it's a run capacitor. If it was a start capacitor, it's only there for a split second. Now let's go over to this beautiful Marathon motor. We've all seen this if you watched any of my videos. This Marathon motor right here. I just had a video I just did, and this motor was a failure in a system. If you haven't seen that video, somebody decided to connect a 20 microfarad capacitor to it, which is going to make it overamp, and well, it's going to damage the windings. It says 1.5 full load amps. I believe I had 3.3 amps on the first video when I was testing it. Capacitor 5 by 370, 20 by 370, or even 440, doesn't matter that second number. So you could use a 440 in place for 370. You cannot change that 5. Can't even put a 7.5 on here, or else you will raise your amps on this. Now here's something that also, besides too large of a capacitor being on here, there's a thing called drain plugs on a rescue motor. That was supposed to be removed. Actually, no, this one stays on. This one was supposed to be removed because it faced down. And what that does is it allows any kind of moisture that may get inside or any condensation to drain. It's pretty simple. So now let's come to testing this. We're going to start at 200. Put the light on. As soon as I put the light on, that's where. Now we're going to start with white and black, L1 and L2. That's good. I have 22 ohms on L1 and L2. Now let's go L1 white. They have labeled as L1 to brown white. Oh look, almost nothing. It's almost like a perfect path of power. Not bad, especially when they are actually connected inside the motor. But you can see 0.4. That means nothing. Now let's check where the capacitor connects to the motor to help create the magnetic force to get this motor going. Uh-oh, look at that, open line. We have an open line. This motor is no good. Let's open this up. Let's see what's inside, if we can spot the failure. One thing I should have done on the job was brushed them. I cleaned them up so this would open up a lot easier, so I wasn't snapping left and right here. Off. We know we have a bad winding, and we know it's a capacitor winding. Let's see how discolored it's gonna be. This motor also wasn't oiled. Our bearing sits in here. my. So moisture definitely played a role in this thing dying. This is all kinds of beat up. Even moisture. Oop, there we go. There's a burn. Right here's a little short inside the motor. I don't know if it shows up, but right here you got a black crispy spot. That's a motor overheating. Also moisture getting inside here, doing a number. There's your windings. I don't see any burn. Yeah, I mean, you got a little corrosion on it, but what worries me more is all the moisture that's been in here. Because somebody didn't take this out. They take that plug out, and then all that moisture has somewhere to go instead of building up inside this motor. Stator, I mean, look at this. The bearing, perfect. Nothing wrong with the bearing. But now that you see on the inside. Oh, I just pretty much made this to show how to test the windings on a motor. Also, so everybody that was believing that I misdiagnosed this motor can see I did not misdiagnose it. I love the challenges anybody has. Do it in a respectful way. This motor is no good. I tore apart this motor. Hopefully you learned how to troubleshoot an electric motor a little bit to see if your windings are bad. Usually if you have power going to your motor, if your capacitor is good, 99% of the time, your motor's shot. 1% of the time, even though the capacitor tested good, on their load it can't handle it. It does happen. But unfortunately for this motor, this thing's been just collecting moisture, and it hasn't been able to drain because nobody pulled that out for a long time. So this rotor stator setup is crap. Till next time, I'm Bill. Thanks for watching.